Hello everyone and welcome to this new video about level design. In this episode, we're going to see how to create a cartoon cloud 3D asset in Blender from modeling to rendering. Our goal will be to make a light asset that is game ready, meaning it could be imported in a game engine like Unity, Unreal Engine or Godot, and used in a real-time 3D scene without taking too much of a toll on the machine. Okay, so in previous episodes of this series, we've talked about the two most common types of Blender objects, the meshes and the curves, and we've seen how to tweak those in various ways, be it by applying modifiers or integrating them in geometry node systems. Today we're gonna explore yet another type of Blender object called the metaballs. We can create one by pressing Shift+A to open the Add menu, and then going to the Metaball submenu, and for example, we can start simple and pick the ball option. You see that this creates an object at the origin of the scene that looks like a basic sphere, except for those two circles surrounding it if we go into edit mode. The larger red circle is a selection ring. It's what you need to click to select this subcomponent of the metaball object and be able to transform it in various ways. The smaller green circle inside represents the influence of this sphere, which we'll talk about in just a second. Now, of course, if we are into edit mode and we select our basic ball, we can then use G to grab it and move it around like we do with normal meshes or curve points. But the real trick happens if we duplicate this sphere and move the second one away from our first ball. With this new ball in our object, you start to see why metaballs are so special. They auto-join the main balls that you define with organic-like bridges, and thus create sort of smooth blobs based on your sphere joints. In a nutshell, metaballs aren't defined neither by vertices like meshes or control points like curves. They are generated procedurally on the fly by Blender thanks to math formulas. These formulas always create this kind of clay or dense fluid-like shapes, and most importantly, two meta objects that are close to each other will interact. They blend and merge just like water droplets, and the higher the influence of one object, the bigger this interaction. So the green circle that we discussed earlier basically controls the stiffness of the meta object. All of this makes it really easy to create our cloud shape, just by duplicating our ball and moving it again and again, optionally using S to scale it up or down, and gradually expanding our blob into a blobby-like cloud form. To further customize our metaball, we can switch back to Object mode and in the Properties panel, play around with our object's data fields. For example, we can reduce the resolution to get a smoother blob overall. We can also change the influence threshold value to have the balls grow or shrink and connect more or less. Once you're satisfied with your shape, it's usually better and easier to go back to an actual mesh, because it will allow you to apply command tools on it. Be careful though, this conversion operation cannot be toggled on and off like a modifier. It's what we call a destructive operation, so you'd better make sure that you like the shape or make a copy of your file before doing it. Anyway, now we have a mesh that has the usual vertices, edges and faces, and you see that because we lowered the resolution size of our metaball earlier, our mesh is actually quite defined, with a really dense grid of vertices. This is fine if you plan on rendering the cloud, but here, since we want to do a low-poly game-ready model, we can take advantage of Blender's Decimate modifier to reduce the complexity and make our mesh lighter. Typically, to make a simple, although slightly blocky model, we can keep the default collapse mode and reduce the ratio to something like 0.03. Of course, feel free to put a higher ratio if you want to keep a smoother shape, or a lower one if you want a really simplified cloud shape. By the way, you can also enable the statistics to check the difference between the base mesh and the decimated version, simply by toggling the modifier display in the scene view with this icon. Once you've found a setting that you like, you can apply the modifier to actually bake the simplified geometry, and if you tab into edit mode, you see that we now have way less vertices. Then if you want to modify your cloud shape a bit, you can use proportional editing by going to the icon at the top or pressing O on your keyboard, and you'll then be able to grab, scale or rotate your vertices as well as the ones next to them. This way you can quickly adapt the overall form of your mesh while keeping it cloudy. Okay, now this object is cool, but if we go into render mode, we see that it just has the grey material that Blender applies by default, which is not that appealing. So in the second part of this video, we're gonna see how to quickly complement our low poly modeling with a toon cel-shaded material and even some render outlines. Let's open up our shader editor panel at the bottom and make sure that we are editing Blender's default material by selecting it for the material slot 1 of our selected cloud object. We see that for now this material contains just two nodes, a principled BSDF and the output. This principled BSDF is a nice built-in blader shading node that gives this simple one-colored lit result that we could even tune to be shiny or matte or partially transparent. A good way to quickly create custom and more toon-like aesthetics in Blender is to follow this principled BSDF node with a shader to RGB node and a color ramp node. As is with the black color at the far left and the white at the far right, and this continuous gradient between the two, we get the exact same thing as we did before. But if we start to bring the left handle to the center, we see we can make our shadow darker. And even better, if we switch from linear to constant mode with the drop-down menu, then we get immediate color changes instead of gradients. And we can play around with our handles to create a fully black and white drone-like cloud. We can of course tint the shadow with some blue color and add an additional intermediate handle to add one more step in our color progression. This makes for an interesting cartoon rendering, and the great thing is that it is still computed from the base lighting system, so it will update automatically if we move the light around the scene. Note that if after applying this material you feel like the decimation we did before was a bit harsh, you can counter it to some extent by using a set division surface modifier. Once again, I'll then use proportional editing to tweak my vertices slightly. My goal would be to make the cloud more puffy and to flatten the bottom part to make it look like most of the cloudiness is above. Last but not least, let's see how to configure our render to add some outlines to our toon cloud. Blender actually offers us yet another built-in tool for this, called Freestyle. So if we go to our render properties and enable Freestyle at the bottom, we see that if we place our camera in front of our object and render the scene, we get our cloud in the middle with this bluish cartoon material and a basic small black stroke all around it. To customize the freestyle options, we can switch over to the View Layer Properties Inspector and scroll down to the freestyle section. Here we can tweak everything from the color to the thickness, the parts of the object that should be contoured, and more. In this example, we'll just work on the thickness. So let's open up this subsection and start by increasing the base thickness. Then we'll also add a noise modifier and change some of its parameters. This will make our stroke more irregular, which is more like a manual drawing contouring. Of course, you can play around with these noise settings to change how big this effect is, but in any case, if we re-render, we now have a bigger stroke with little irregularities. For the final touch, don't forget that you can also go to the render properties and change the film to transparent, to render and save your result as a PNG with a transparent background. Anyway, on that note, that's it for today. I hope you enjoyed this 3D asset creation tutorial and that you've learned a few things to creating a cartoon cloud in Blender. If you did, feel free to like the video and subscribe to the channel to not miss the next ones. And of course, don't hesitate to leave a comment with your own ideas for future level design tutorials. As always, thanks for watching and take care.